Hello, everybody. Welcome to the InvArch Tinkernet launch event. I can see that we have some viewers watching us right now. If you don't know, my name is AJ. I'm the social media manager for InvArch, and we have the InvArch's very own co-founder and a senior Rust engineer, Gabriel.
Hello, guys. What's up? I know you guys can really respond to that immediately, but
Alrighty, we'll just take a few minutes to allow people to come in, join the live stream, and let's get this party started. That's awesome. That's so cool.
Wake up, guy. Tinker Testnet launch. Don't miss this opportunity. I love that. So here's the thing. What should be the very first IPF to be minted?
Ooh. By you or by our devs?
I mean, anyone with tokens can mint an IPF right now. But this will be the very first. It should be special. Should have something.
That would be, yeah. That would be pretty cool to see which or what's like minted first.
Maybe we should ask Twitter.
Yeah, I will do that right now.
Ooh. Yeah, bot's working.
Beautiful.
Let's see, what are we gonna mint? Ooh. What about? Let's see. I was gonna say, what if we mint the whole the whole node binary, but that's 140 megabytes. Then we would be minting. We will be minting InvArch itself.
Yeah.
Could mint the runtime itself. Could like the source code for the runtime. Let's just. In fact, I'll leave this here just for later.
Yeah. Alrighty. Matthias said Sora enhance.png.
Oh, that's a photoshopped image that I have in my images folder that I'm afraid I cannot show.
But yes, everybody, we are now live. The Testnet, aka InvArch Tinkernet, is now live and ready for your tinkering. Hello, Dimitri. Feed. Did you get to mint something, Gabe?
Hmm?
Did you get to mint something?
No, I still haven't.
Oh, okay. Why don't we?
I mean, I could mint something, but I think it would be more interesting if we see who in the community gets to mint first.
Right. 100%. But that being underway, let's talk about what were the issues and how you were able to mitigate them and to eventually launch right now.
Yeah. So what happened was we were on track to get upgraded to a parachain to get a slot on Rococo, which is the relay chain we are using for the testnet. And we were coordinating everything with Parity directly. So what happened was we encountered an issue where our parachain couldn't produce blocks. So the way that block production works in Polkadot and usually most substrate chains is that we have consensus separate into two different parts. One part verifies blocks and the other part produces blocks. This is important for parachains because that means you can have a relay chain, in this case Rococo, or for example Polkadot, to verify blocks, while the parachains themselves produce their own blocks. So they produce blocks, and then they send to the relay chain to get validated. So what happened was we were launching our chain, but we couldn't get any of our collator nodes, which are the ones that produce blocks, to connect. And if we cannot produce any blocks, that means we cannot manually add any other collators. So we were back and forth with Parity to get to like restart the whole chain with re-verifying the parameters we were setting to see what went wrong, and we managed to get a set of collators running. So now this means we have control over the collators. We can now add a bit more. We can change them. As soon as block production starts, we gain control over the network. But without the first block ever being produced, there's nothing we can do besides restarting the whole thing. And that's what took most time. Restarting everything takes a lot of time because, for example, just to get a parathread, which is just to get registered in the relay chain, it takes 2 hours. And then just to get the parathread to become a parachain, it takes another 2 hours. So it's every step of the process is like 2 hours to wait. And then we had to debug while doing that, and that's why we had to delay it a bit. We hit a bump in the road, but here we are now. It's all working. We managed to pull through, and yeah, you guys can now join the testnet fine, and we'll be looking into also allowing more people to join as collators if you guys want that.
Yeah, that's awesome. Awesome. Thank you, Gabe. And I'm pretty sure the community appreciates all that, and it's exciting to finally have a testnet running, and also running the testnet, aka Tinkernet. So.
So I believe what we should do, before we start talking about the features, what we could do is we could instruct people on how to use the bot, because then they can follow along as we explore features.
Yeah, 100%.
So first thing, to get in the Tinkernet page in Polkadot.js, we have our chain here in the Rococo dropdown, but this is currently unavailable. We are working with functionality to get this domain that they have registered to connect. But for now, we have a URL. So what we can do is I can get this whole thing, and I can share this. If you go to this URL, you go directly to the correct chain and the correct endpoint. So what I'm gonna do is I'll just send this in chat, and then if you want to, AJ, you can put this in announcements or post it to Twitter.
Yeah, for sure.
Good. Let's get the Explorer page. There it is. Okay, and once you're there, you'll be in this screen. This is the Network Explorer. This is where you see the blocks coming and also the events. So if I do if I call any function, anything that produces events, it will show up here. And if I have this page open and other people start interacting with the chain, it'll also show those events. So this way we can see what's going on, what's happening, what people are doing. And then here in accounts, if you have the Polkadot.js extension installed, it should automatically inject your accounts. It's important. You need the Polkadot.js extension to be able to use Polkadot.js itself. To get the extension, if you don't have it, you just go to polkadot.js.org, and you'll be in this page. And then in this block here, you can see the link to the extension. So that goes to polkadot.js.org/extension. And then it has links for Chrome and Firefox. Okay, so I have here a couple accounts. I have here, for example, this Gabe account. It has right now 10,000 Tinker. To demonstrate the bot, I'm going to fund this. So right now the bot's set to fund 10,000 Tinker per request. So if I fund this again, it will be at 20,000. So let's copy the address. Let's go over to Discord, and I believe the bot will work in any channel. So the command to fund is /fund wallet, like this. This should show up if you just type the slash. It will show up this there. If it doesn't show up at first, you can start typing fund, and it should be the only command available with that name. And then you just paste your wallet next to it. Then you can send that message. Ooh, okay. No problem. We can just restart that. But again, it happens. Okay, there we go. Funding call submitted on chain. It will take a couple seconds to. There we go. If you see here in the Explorer page, it will show that it was transferred from the Tinker root. So this account currently we are using it as the account that holds. It's the root account. It's the one with pseudo privileges, and it also holds all the tokens. So every time you use the bot will make this account send you tokens. So that's a simple way to do. Instead of minting tokens, we just send them. And as you can see, this account now has 20,000 Tinker. So following that, let's also show the extrinsics page. We also showed this in the guide. So here you can go into you can select first you select your account, the account you want to call that specific function, and then here you have the modules. So most of these are very default substrate modules. The most interesting ones here that you're going to see that you're not going to see anywhere else are the IP modules. So IPF, IPS, and IPT, they are part of the InvArch set of modules. IPFs are for IP files, IPSs are for IP sets, and IPTs are for IP tokens. So if you go to IPF and you mint, this will give you two fields. The first one is metadata. This is labeled as bytes, which means anything you type here will go. So for example, if I type test, it will be accepted. So right now we don't have any DApp, but in the future when we start seeing DApps popping up in InvArch, when we eventually have a mainnet, this metadata field will be used by those DApps, and we do see these being used for file extension, for file category, for all sorts of things. And then here in data, this is how we store actual NFT data on InvArch. We have we use IPFS and we store the hash from IPFS CIDs. So to demonstrate this, you can go here. Polkadot has this nice IPFS module here that you can go in the developer tab, files. This will, sometimes it does that. Polkadot. But while that loads, I'll explain this. When you go to that module, IPFS module, you'll be able to mint files into IPFS without having to use any external node. That's a service provided to all chains running, and you can access that directly via Polkadot. And it's important to have this open too. CAD inspector here. So let me demonstrate why you need this. So for example, I have this file here. This is the CID of that file. CID in IPFS is the identifier. This is like the location of the file, and it also represents the file itself. If I copy the CID and I plug in here, I'll see that it converts the CID to the hex. If you go down here, it's in multi-hash and it digests. And you just copy this, and back there in the extrinsics tab, in the IPF module, mint function, you can see the metadata and data. So if I drop this here, prefixing with 0x, because this is hex, and there it is. This will actually, if I submit this will go through. I don't want to do this right now because I want to see someone mint the very first IPF, and that one's what it is. So let's keep going. So I think it will be more interesting if instead of calling any functions myself, I just explain them and see how people use them. So for IPS, the main function here would be create IPS. You also type the same metadata types that you have in IPF, and then this a vector of IDs. You can add as many as you want here. These are IPF IDs. So let's say you want to make like in the example we showed in the guide. If you want to make an album as an IPS, you would have each track of the album, each music, as an IPF, and you would add them here. So if you minted IPF number 0, number 1, number 2, number 3, you would add them here. So 1, 2, 3, and this last field, this is a boolean. This is a yes or no. It's for allow replica. If you set this to yes, anyone will be able to create a replica of your IPS. That replica will be marked. It will not be just like another IPS. It will behave like one, but it will have a field saying that it's a replica, and it will always point to the original. So it will have the field replica and the ID of your IPS. And here you also have the other functions that allow for composability. For example, append lets you add more IPSs or IPFs inside your already existing IPS. The remove function, it does the same in reverse. It lets you remove things from inside your IPS. Then you have the allow and disallow replica functions. Those just change that one field that lets people create replicas of your IPS. And then we have the create replica function. This is what you use to actually create one. So you type the ID of the original IPS here, do some transaction, and you have yourself a new IPS, replica. And then every time you create an IPS, it will create a token class for you, and you'll create an IPT, and then it will automatically mint the existential deposit for your account. So if I were to create IPS and that IPS were to be ID 0, I would automatically have IPT ID 0. And then to do anything on it, I will have to use multisig, which we have functions for multisig here. So operate multisig lets you act on chain, but instead of using your account, instead of calling from your account, it would then replicate the IPS account. So if I do this and I type IPS ID 0, and then I can call any function here. It's the same function selector that it has here. You have an inner one. And then, for example, if I were to mint an IPF here, the owner of this IPF would not be me. It would be the IPS account. And then you can, using this, you can then go inside IPT again, and you can burn tokens, you can mint tokens. You can, from outside here, you can vote multisig. Because right now, we have hard-coded that every multisig call needs at least 50% of ownership to run. What that means is, so if I were to make IPS, I would automatically have 100% ownership of its IPTs. If I were to call a multisig, that would pass instantly. If then I instead mint to someone else the same amount of IPTs that I have, that will make me have 50% of the total supply. So if I were to call the operate multisig function, it would instead of running the actual function from inside, it would start voting. And the other user that has the other tokens, they can come here, they can vote, they can type the IPS ID, the call hash that your operation generated, and that would include their vote. Once that those votes surpass 50% of the total IPT supply for that IPS, then the call also executes. And then you can also withdraw votes and all that. There are a bunch of helper functions in all of these. IPF is a simpler one, has a mint and burn. And so I want to see now people start minting tokens. I want to see what people come up with. Let's check Discord. No, the testnet is not going to be rewarded. This is an incentivized testnet. Unincentivized, sorry. Polkadot.js, I'm gonna read questions. How convenient is the functionality of Polkadot.js for the testnet? So Polkadot.js, it's not the most convenient tool for everyone. Polkadot.js is an interface for developers, and the good thing about having Polkadot.js is that when you are trying out features, when you are testing out modules, for example, and backend for Parachain, you don't have to create a whole UI for users to test. You have this already done. This works with any substrate chain. You can connect to any chain from here, and it has everything that you need in that for that chain. So this is not very user friendly. This is actually very complicated because there are a lot of information that most people will not use. But this is also very useful for developers. And since this is already here, this is usually what people use for testnets, because you can focus on making your backend instead of having to, every time you run a testnet, you will have to make a new front end for those modules that you created. And for this, for example, if I were to create a new module right now and put it chain, it would show up here. It would be here in this list. I wouldn't have to program anything for the interface.
We also have another question, Gabe. Somebody, let me just get the name. Vas number 6118, I believe from our Discord community, asked, what are the system requirements for the node? Or I guess, what would you recommend?
Let me see. So right now we are running a full node with a 4-core CPU, 16 gigs of RAM, and 50 gigabyte storage. Actually, our full node is running at 100, but I believe it should work with 50 gigabytes. Let's see. I also believe you could run a collator with half that for CPUs, like with 3 CPU cores. That should be fine. I'm running 2 collators on my machine right now. You can check what those are using. Let's see. InvArch collators. So this is using 1.3% of although yeah, I have a lot of CPU cores, but it's not using that many resources. It's using 6% of my memory too, and I'm actually running 2, so it's using a lot more than it would. But of course, these would only go up as we approach mainnet, because we will be adding more and more features. We will have more and more data running on the chain. So resource usage right now should be as low as possible. Like in the first testnet, the initial state of mainnet would also be the same. But as time goes on, blockchains tend to start requiring more and more resources. It shouldn't be anything crazy though. It should be pretty standard for substrate chains.
Awesome. And so, Gabe, would you say, which Kresna mentioned in our chat, but a 4-core CPU, 16 gig RAM, and a 50 gig storage? Would that be?
Yeah, I believe that will be more than enough.
Beautiful. Beautiful. We do have more questions, so let's go through them. Let's see. So from Cap, one of our core moderators, could you show us how to create an IPS with or 2 IPFs? So an example, I believe it's pretty much like we showed in the video guide, 2 music tracks that he gave.
Yeah, so to create an IPS, you will go to first developer, string 6, IPS, and then you have the IPS functions. What you want to use is create IPS. And for metadata, you could back to IPSs. So in the IPS module, create IPS. So here you have 3 fields that you have to fill. Metadata, this you can write anything in here. This would only be useful for later when we have dApps running. This would be the way that dApps would identify the data that they are storing. You would use this to basically as normal metadata that you have in NFTs, for example. You can put any identifiers in here. Let's just write that here. And then in data, you have a list of items. You can add as many as you want. These are IPF IDs. When you create an IPF, it generates an ID, and then you can use them here to add them to your IPS which you're creating. And the last field is all replica. You can set this to either yes or no. This is pretty self-explanatory. Let's mint something. What will we mint? Let's mint code. I have already here this lib.rs file. This is the source code for the runtime for InvArch, at least for this version, for the testnet. So why not? Let's mint InvArch and InvArch. String 6. Actually, let's put this here. We get the digest hex, and then back in here, IPF mint metadata. Let's call this lib.rs. Let's call it InvArch Tinkernet runtime lib.rs, and then the data here. There we go. Submit transaction. Fees of 1.7 millitink. That's a pretty low fee. Let's sign this. There we go. IPF minted. IPF. Then it shows you the account, the minted, the ID of the IPF, and the data. So now that I have this, I can, for example, go in developer, change state, and if I go to the IPF module, I can query in this one IPF storage. If I use ID 0, it will show there. Owner, that's my account, 5H Gabe. Author, the reason we have owner and author is that an author can never change, it's immutable. You created that, no one else can claim they created that. But if you transfer that to someone else, transfer ownership over that, then the owner field will change. But it will still have a field registered that you were the original author. And the metadata that I typed there, and the data itself. So this data, we could do the reverse of what we did here. I would need actually I believe I have something right now to do that. Let's see. Actually, I have that somewhere in my. Let me grab my other monitor here. I have code to do that. Okay. Now let's get this code that I have here. Source main. All right. So now we can plop the hash over here. Let's go back to that. IPF, storage, 0. There it is. That's a hash. We plop this here with prefix 0x 1220, I believe it is. Yes. And that's this. Okay. Cargo run should print that. Oh, right. Let's remove this. There we go. We got this back. Open this and we wait for our IPFS to find where our file storage is stored. There we go. That's a file. That's the runtime for InvArch. Okay, InvArch modules here. So basically, this is how you go the reverse way from there. This would be actually implemented in code in a dep, for example. But this is showing that we don't store CID because CIDs like this they're not easy to store. They take more space. This is with all this encoding for letters in lower and uppercase. What we do store is just a hash, which is hexadecimal. This doesn't cost us a lot of space, and it accomplishes the same thing. And then you're showing file. And for example, let's also mint. Where is it? Node. Let's also mint the lib.rs file for the node. And then let's create an IPS for those. Where is it? Which one was it now? Wait. This one is for the node. Okay. String6, IPF, mint, InvArch Tinkernet, node, lib.rs. Metadata. Submit transaction. Sign that. And it will show up here. IPF minted. IPF ID 1. Yeah. So we have 0 and 1. There we go. It's in the block. What we can then do is go back to String6, IPS, create IPS. Let's call this InvArch Tinkernet. And let's add both 0 and 1, the two files that we created. That's our replica. So why not? Sign and submit also costs almost nothing in fees. And then we can just come back here to the Network Explorer tab and wait for it to show up in events. There we go. IPS created. This is the IPS account. This is what you use for multisigs to act as the IPS itself. There we go. We go to change state and we query IPS storage. That created the first IPS in the chain. That's ID 0. And there we go. This is the IPS account. Metadata, InvArch Tinkernet. Data, the IDs of the two IPFs. that we minted and we added here. It's a normal IPS and a replica. Now we can also query IPTs. So if you see select state query IPT and the storage IPT itself, if we query the same exact ID from the IPS, which is 0, we'll get this same account here as the owner, supply of extension deposit, and then if we do balances and query, we can query an account here with ID 0. We can also remove that option, and it will show all the accounts that have balances in this type IPT, and it will show that it was me, Savage Gabe, and I have that amount. Then I can start acting as that IPS. I can go to IPT, operate multisig, IPS ID 0, and then I can do any call here that I want. I can do IPT again, mint, again IPS ID 0, amount. Let's mint this amount. This is less than 0, for example, because the way we do balances in Polkadot.js is you have to do them in integers instead of floats. So this number would be this amount of this will be the total number counting all of the decimal places. We have 12 decimal places, so this will be less than 0 because it doesn't get followed by 12 zeros. And then let's mint to Gabe 2. Simple. So I submit. Then we can come here in the Explorer, and this should be interesting. It will show both calls happening. There we go. IPT multisig executed. This is the multisig account. This is the call that I actually made, which is IPT mint, and this shows that it worked. This boolean down here, it represents if the inner call passed or if it failed, and this is the inner call. IPT minted, Gabe 2, this amount. We can confirm this by going into change state, IPT, and balances. We can remove this. Let's see all balances for IPT 0. Oh, sorry. Yeah. Let's restart this. No, probably. So this connection fluctuates quite a bit. There we go. IPT, balance. Let's query that again. There we go. Now it shows that the account that I minted to has that amount that I minted, and my original amounts here show all the balances of that IPT. So this is basically our version of Ballot assets merged with our version of Ballot multisig. It's all in one. It does all the functions in one ballot. There is also the multisig storage query. This is not going to show anything, but if there was, let me demonstrate that. I'll go here, and then as the other account, the account that doesn't have at least 50% ownership, I'll do the same thing. I'll operate multisig. Let's burn, for example, or let's burn. Let's burn 100 tokens from the original account. If I place this call, let me transfer that. If I place this call, this is going to become an event. It's going to say that the vote started, and it doesn't mean that it gets executed. There we go. Multisig vote started. The IPS account, the amount of tokens that have been voted, the amount of tokens, the total amount of tokens in the IPS. So you need half of this at least half of this to pass this call, and this is not that amount. And then the call here. This is the call hash. I can come here and copy this. Actually, let's go first change state. IPT, multisig. And there it is. that storage with that call. If I go to extrinsics, and then as the game account, IPT, vote multisig, and then I use that call hash. And here, since this account has over 50% by itself, the moment that I vote with it, it's going to approve it, and it's going to execute. So if I vote, sign transaction, oh great, it lost connection again. Let's just wait a second here for it to reconnect. Discord. Go should back up now. There we go. Now let's see if that extrinsic executed. We can, since we didn't see if it actually executed or not, we can go back to the storage and we can check it. And there it is. It wasn't executed. So let's try again. Let's go to IPT, vote multisig, and the call hash. Submit transaction, sign and submit. Sign. And now we can wait here in events. And there we go. IT multisig executed, it got approved, and then the call that we actually ran with it, which is the burn. And just to show why we need to do this, show what happens if you try to, for example, as game2 IPT burn, and I try to burn that without going through the multisig process, without starting a multisig operation. You see the error that's going to show. There we go. IPT no permission, because to operate inside an IPS, inside an IPT, you need to be that IPT IPS. And the way the architecture works is that you use that data as if you were like a DAO, for example. This is one of the nice features about InvArch, of the architecture, is that everything is basically a DAO. You can make anything into a DAO in your architecture. So you have to vote for that DAO to execute that action. And as IPT holder, you have power to do that. The IPTs themselves represent, they can, and at the same time they cannot represent ownership. It's the choice of whoever's implementing an application in the chain. For this example, we are using them to represent ownership. And then if I have at least 50%, actually it's over 50%, so it would be like 50.0001%. That would work too. And then it would execute those calls. So then I can also show, for example, IPS. Let's create a replica. I believe the 0 allows replica, right? Let's try that. Network Explorer. There we go. Replica created. It's ID1. Let's go to change state IPS. And let's check ID1. There we go. It's same metadata, different parent though, different IPS accounts. It will never allow replicas because it's a replica. Right now, this is hard coded, but in the future with licensing features, that might be there might be a replica IPSs that also allow replicas themselves. And an IPS type, instead of saying normal, it says that it's a replica, and then it points to the original. This is the ID of the original. You can then check back here, and you can see there it is. And then I could append data here, for example. So, for example, files. Let's grab any of these files. This is, I believe, my Discord profile picture. Let's plop that here. Let's get the digest hacks. String 6. Gabe 2 is the owner of IPS ID 1. Then Gabe 2 goes to IPT, operate multisig, and then since actually I forgot to mint the IPF first. Sorry. Let's do that here. Gabe dfb.png. There we go. Let's see the ID of that first. It's ID 2. Okay. So back to Extreme 6. IPT, operate multisig. Since Gabe owns that IPF, the only way to let the multisig functionality know that it's Gabe himself that's trying to mint it is to use this include caller. This will allow you to include yourself in that function, and then when you try to append an IPF that you own, the function will be able to check your account that you own that. So IPS ID 1, we want to append that to IPS ID 1, and then as the inner function, we do IPS append again IPS ID 1, and then we can add items here to add what we want to append. Let's append IPF ID 2. And let's submit transaction. Let's sign that. Go back to an Explorer. There we go. Multisig executed. IPS appended. If we go here now to change state, IPS storage ID 1. There we go. So it's a replica of IPS 0. But we can see that we just added another IPF to it, which doesn't exist in the original IPF 82. So this is basic functionality. There's a lot you can explore with this. There's what we want people to start thinking with this testnet is not how can you use this functionality manually like I'm doing here. What we want you guys to look at and think about is how can I implement an application in this protocol? How can I implement something that might benefit from this extensive functionality for IP management? There are a lot of areas that do benefit a lot from this. The music industry, for example, the use case we showed, you could write it that uses InvArch technology, the InvArch protocol, to make music publishing on the blockchain without going through a label. And this is the kind of thing we want people to start coming up with the testnet. We want people to be able to explore the functionality, write that down, and then use that to create something awesome. So we also very much look forward to seeing your feedback and what use cases you guys come up with.
Yeah, and don't forget, like, this is literally your guys' playground, your sandbox until the end of the month. So not only have fun, but see what you can break, see what you can find. If there's anything, any other ideas in terms of use cases that you may have while you're tinkering, please let us know. Reach out to us on Twitter, Discord, all of our other platforms, and we truly want to know. That way we can, build, like I said in the video, we can build the best technology, which is InvArch protocol. So
yeah, we are building this for the community. So it's important to know what the community wants from it. Because if we build something that no one in the community wants, then there's no purpose. So yeah, we're really looking forward to seeing what you guys want to do with this, what you guys want possibly to change, what features you guys would like implemented. If there's any details that maybe you guys think would be better differently, then do let us know. We'll be always on Discord, Twitter, looking forward to the feedback.
Definitely. Just to answer some questions before we let everyone go. So I wanted to address, let's see here. We have, I believe, Anton 1982. When will the testnet be available for everyone?
It is available for everyone right now. So we still don't have this still doesn't work. If you go to Polkadot.js and then top left corner, and then you click test for Cocoa parachains, it should have InvArch Tinkernet listed there. But right now this doesn't work. We're working with Finality to fix this endpoint there, and we will let you guys know once that's fixed. But for right now, we can share this. I can share this URL, this raw URL that goes directly to the endpoint, and I'll send this here again in the Discord chat, and I'll pin this. But we'll be putting this in an announcement, I believe.
Yeah, and that has also been broadcasted to our Twitter, so you can find that, I believe, specifically under my Twitter account, so at CryptoAJ and you'll be able to find that link as well. And then he also had a secondary question. Will there be bridges for other networks besides Polkadot? I believe he meant Polkadot.
Yeah, not in the testnet. This is not the scope right now, but I believe that is one of the main ideas that we want to do for the XCA protocol, for the cross-chain authentication. Because the cross-chain authentication protocol it relies on cross-chain messaging, which is a cross-consensus messaging, which is a protocol that we can use as a parachain in the Polkadot ecosystem. And one of the features planned for XCM, which would then extend also to XCA, is doing XCM over bridges and then XCA over bridges, which then would allow us to do communication directly with bridges going to other blockchains.
And our fellow team member, Mateus, he also asked, is the bot already working?
Yeah, it is. It's /fund, it will show the command, and then it's /fund_wallet, and then you paste your wallet, and then it should send tokens to your accounts.
Beautiful. Yeah, I believe that's all the questions that were sent in. Just double check Twitter and Discord. Perfect. Yeah, so again, everybody, thank you so much for all of those that came out to the InvArch Tinkernet launch event. This is the first time that we've actually done something like this, and I believe, you know, I mean, not believe, but I feel it was pretty fun. It's truly awesome working alongside Gabe, and to really bring finally the initial run of the testnet to you, and again, please, you know, make this your little world for, you know, until the next, you know, couple of days until the end of the month. Find what you can, break what you can. See what you can do. Like Gabe said, this is an opportunity for all of you, specifically who are developers. You know, like how can I implement something in this protocol? What can I do further with at least for now the basic InvArch technology that is available via the Tinkernet. So do what you can, explore, have fun. And with that being said, I believe we can finally send them off into Tinker. To Tinker.
Awesome, yeah. So definitely go tinker with the Tinkernet, and I'm really looking forward to what you guys come up with.
Awesome. Alrighty, thank you everybody, and keep in touch. Again, reach out to us through Twitter, through Discord, etc., etc. You know, our social profiles are all over the web, and we'll be there to answer your questions, your concerns, and to help you out if you need assistance with the testnet.
Exactly. Yeah.
Alrighty. See you later. Take care.
See you guys. Bye bye.